Welcome to the video accompaniment to StackQL version 0.3. Today we're going to set up StackQL for authentication first. We're going to talk to the Google and Amazon systems using traditional patterns for each, those being a Google Service Account JSON key and Amazon environment variables. Then we're going to start an interactive session of StackQL, download what we call registry documents, which are effectively interface definitions which enable us to talk to the systems, those being Google and Amazon. We're going to then interrogate those documents a bit, figure out how we can interact, or just demonstrate how we can interact with them. Then we're going to create and then list out some disks, and then finally delete those, and that'll be the finish. Okay, so we're in the StackQL interactive session. Let's pull those registry documents. There we go. Pull the Google one down. You'll see the version. Yep, no problem. Same thing with Amazon. Now we're just going to issue some meta commands and just sort of interrogate the provider service resource hierarchy that we have for Google in this case. And after that, we'll sort of do a bit of a cheat and just insert a disk or create a disk for each of the systems, and then we'll go from there. So these meta commands have a fair bit of flexibility, and they certainly can expose a lot of the information of interest. So we get down through service level, looking at the resources that are present inside a given service. So the Google Compute service contains these block storage devices, which are used by compute engine virtual machines. There they are, second from top, right there, Google Compute disks. We can describe that. Describe will just tell us what the object looks like itself, and so then what we're going to select and what we're going to create. There we go. Lots of stuff. So to keep a long story short, when it comes to selection, we're going to use projections. Now, when it comes to creating a Google disk, Google is one of the more richly annotated registry documents we have, so we can use this await directive that you see here, insert await. That means we're just going to poll and make sure that the disk insert, the disk creation proceeds to completion. We don't have that luxury with all providers because they're not all as richly annotated as Google. We are working on it. Okay, so Amazon. We don't have that annotation for AWS EC2 just yet, so we just have an optimistic philosophy. We just fire the request and we can check whether it's worked or not. So let's have a look. Let's do some read operations. Let's just select some of the data out of Google Disk. There's a fair bit going on here because this is one of our test environments. We've got lots of different tests and demos running, so loads of stuff here. Quite interesting. Disks of all different sizes. Amazon, same deal basically. See a lot of the disk statuses, a lot of them are in use. That's going to restrict the operations we can do on them. So for instance, if you try to delete a disk that's in use, it just will not work. Now, we can actually union together Google and Amazon data and get a multi-cloud or a dual cloud view in this case. You can do it across many regions, many providers, all types of things, So this is just a bit of a taste of some of the stuff that StackQL can do in terms of audit and audit and interrogation of your cloud estate. Okay, so loads of in-use disks there, like I was talking about before. We can create a view just so that we don't have to constantly cut and paste or type over and over again. And that view we can use, order by. We can do filtering, all kinds of things on it. So let's order by the name. Cool. Yep. Descending name order. Yep. So all there we go. Yep. There's a couple of available Amazon disks there. One of those will be the ones we just created. We didn't actually capture the ID when we were creating it, but it's going to be one of those too. Okay, so there is the Google disk we just created. We had the luxury of giving that one a name. Okay. So that one we would definitely want to rub out. We just created it, so let's clean up after ourselves. Again, we'll use the cheating advantage of the polling. So we're going to use the await annotation. It'll just poll every 10 seconds or so. There we go. Right, cool, it worked. Now let's get rid of one of these two Amazon disks that are available, just by way of a demonstration. And then if we look at this view again, having done all of that, we ought to see a couple less disks. And then after that, we're done. Okay. Again, it's just going to be optimistic with the Amazon. We'll check it. Okay, let's have a look again. Okay, well, straight away, there's only one available disk. If you really want to check, you can verify that it was, in fact, the one that we targeted that's been deleted. It's a bit of a jumble, a bit of a hash jumble of letters and numbers. The Google one, for sure, with the unique name is now gone. So that's pretty much the end of it. It's a success, and we can just finish.